So in today's video, we're going to be learning about the skewness of a dataset, or we can say the skewness of a frequency distribution. Sometimes you can also say the skewness of a probability distribution. So that being said, the first step is for us to define skewness in the simplest way that we can think of. So what is skewness? So in the basic terms, or in the simple terms, a skewness is simply the measure of the asymmetric properties of a dataset or a frequency distribution or a probability distribution. So before I try to dive into the concept of skewness properly, I would like to give us a context, a bit of a summary, or the reason why we have skewness in the world of statistics. You see, the basis of statistics is to work on a dataset and use the details from this dataset to make real life conclusions or solve real life problems. And there are several ways the statistics procedure go about this, and one of them is the usage of the numerical analysis. The numerical analysis, such as the measure of central tendency and the measure of dispersion, are meant to give us an insight of how the variables in the dataset interact with each other to tell us the story that they tell us. So for example, the mean tells us the center, the median tells us the center, the mode tells us the value that occurs the most, the measure of dispersion tells us the spread of a dataset. So in as much as the numerical analysis is actually very important in statistics, alongside the visual analysis such as the usage of bar charts, the pie chart, the histogram, and all other graphical tools, sometimes when you know the shape of a distribution, it actually can give you a whole lot of information about the dataset, and this is where the concept of skewness and kurtosis comes inside. It is all about the shape of the distribution. So I'm going to use a typical example of a dataset to explain the concept of skewness. So let's start with this dataset that we have right here, and as you can see, this dataset is actually a grouped data, and to be precise, it is a grouped data based on class. You can see that we have the first class, we have the second class, we have the third class, down to the sixth class. Now, if I want to perform the simple statistical procedure, the first step is for me to graphically analyze this dataset. By graphically analyzing this dataset, it simply implies that I want to use any of the graphical tools rather. So I would be using an histogram to graphically illustrate this dataset. And if you decide to plot the histogram, on the vertical axis we have the frequency, and on the horizontal axis we have each of the classes. And here is what the histogram of this dataset of ours looks like. Now, we can also decide to do a bit of mathematical analysis, just manipulations, and instead of using the frequency to construct the histogram, I can decide to use the relative frequency. So that means the formula for the relative frequency is simply the frequency of each of the variables divided by the total frequency. So if I decide to reconstruct my table, or I can say to rewire my table, I am going to be having a relative frequency column next to that of the frequency, and this is what the table looks like at the moment. And now I can decide to plot the histogram for this dataset by plotting the relative frequency on the vertical axis and the classes on the horizontal axis, and here is what we're going to have as our histogram. As you can see, the graph of the histogram when we use the frequency and the graph of the histogram when we use the relative frequency actually have the same shape. Now, I would like to go further by actually superimposing a curve on either of these two histograms, and when I do that, I'll be having what we call a frequency distribution curve. When I superimpose a curve on the histogram, I would be able to have a frequency distribution curve that will tell me the shape of the dataset, and this is what our frequency distribution curve looks like. So as you can see, from the frequency distribution curve, or from the curve in short, we can see the shape of the distribution. We can see that we have some highs, we have some lows. Whenever we have a frequency curve of this nature, we can be able to talk about the skewness and the kurtosis of the dataset. In a layman's term, the word skewness simply means a form of bias in statistics. Whenever something is skewed, in simple terms, it implies that that thing is actually tilting either towards the right or towards the left. That is, there is actually a form of bias. That is, there is no balance in quotes. So skewness is synonymous to the word asymmetricness. So when something is not skewed, it is said to be symmetrical. So let's quickly rush over it. So skewness is actually synonymous to asymmetricness, and non-skewness is synonymous to symmetricness. So when it comes to the word of skewness, I like to say that we have 3 types of skewness. And the first one being the fact that we have what we call a right skewness or a positive skewness. The second one is when we have what we call a left skewness or a negative skewness. And the last one is what we call zero skewness, or what we say no skewness. For the right skewed data, or whenever we have a positively skewed data, it simply implies that for a distribution, most of the data set, or most of the variables rather, cluster around the left side of the distribution, and the tail of the distribution points towards the right. And for a left skewed or a negatively skewed data set, it simply implies that for this type of distribution, most of the data set actually cluster, or most of the variables in the data set rather, actually cluster towards the right, and the tail of the distribution is pointing towards the left. And when we have a no skewness, it simply implies that none of the variables in the data set cluster either towards the right or towards the left. It simply implies that for this type of data set, the variables are perfectly balanced towards the left and towards the right. So, and a typical example of a distribution that has a perfectly balanced variable is a normal distribution. So most times the normal distribution is always seen as a symmetric distribution. We have other types of symmetric distribution in the world of statistics. The uniform distribution is also a type of symmetric distribution, but our attention is not on symmetric distribution. Our attention this time is on skewness, which is the measure of the asymmetric properties of a distribution. So that means we are all about asymmetricness in a distribution. Now, that being said, there are actually numbers that we can use to quantify the skewness of a distribution. That is, we can have a number that says, oh, this distribution is more skewed than that distribution. That distribution is less skewed than that distribution. Oh, this distribution is more positively skewed or more negatively skewed compared to that distribution. And there are 2 numbers of such. We have what we call the momental skewness, and we have what we call the Pearson's skewness coefficient. And these are the 2 numbers we use to quantify the skewness of a data set. So these 2 numbers will be discussed in the next video about skewness. Thanks for making it to the end of this video. If you enjoyed this video and you learned something new, I would really appreciate if you can subscribe to this YouTube channel and turn on your notifications to get notified when I release new video. We'll see you in the next one. Bye for now.